Previously on The Great Porting. I said that I couldn't port Scratch to the DS. Something about RAM limits, it'll be too slow, blah blah blah, whatever. No one likes past Nate. I'm still however many months, 1 year, into my C++ journey, and I've gone from a game dev noob to still a game dev noob. Nate Pong is still my only public game. So if I want to put some respect on my name, I'll have to go from being the Scratch 3DS guy to the Scratch DS guy. Should be pretty easy. Surely I won't spend the next couple of months doing this. Well, the DS and 3DS are pretty similar consoles, right? They both have a similar form factor, dual screens, and while yes, the DS obviously doesn't have a stereoscopic 3D screen or a circle pad, developing for the DS should still be pretty similar to the 3DS, right? They're like the same thing almost. You could just put the 3DS version of Scratch onto the DS and it's barbecue chicken from there, simple as that. Wrong! You couldn't be so much further from the truth. The DS's hardware, even for the time, was so incredibly underpowered. 4 megabytes of RAM. You know how much RAM is in your phone? A lot. 4 megabytes even at the time was incredibly low. So low in fact that when Nintendo wanted to make a web browser for the DS, they had to sell extra RAM for it to even work. Scratch, and by extension JavaScript, and by extension pretty much any easy to use programming language, is both RAM and CPU heavy. It's why you don't really see many DS homebrew ports of games, game engines, frameworks, what have you. It's a ton of work with frankly very little reward, so you really just gotta be doing it for the love of the game. It's like they always say, limitation breeds creativity, or something. Which I guess is true, since newer consoles like the Switch have infinite power and no limitations. And have you seen the amount of slop on the eShop lately? So then there's me. I'm bored out of my mind. I see the 27th comment on my last video asking me to port Scratch everywhere to the DS. I see Game of Toby porting Mario 64 and Minecraft to the DS. Like, realistically, how hard could it really be? But I have to be smart about this. Scratch everywhere, it's a pretty big project now, made in modern C++. The DS is a 22-year-old handheld. No way this is just gonna work without some pretty drastic changes. So to start, I first decided to see if I could get a headless version to work, meaning there would be no graphics, no sound, no input, but projects and all of their blocks would still be working in the background. But even with that, I still didn't think it would compile, so to save time, I went to one of Polymars's old DS games from 6 or 7 years ago and stole his makefile. If you don't know, a makefile is a text file with a bunch of magic cryptic words made up by some random guy 50 years ago, and it's used to give instructions to the compiler to turn your readable code into assembly instructions that can run on your device. Nobody, and I mean nobody, likes writing makefiles. So yeah, I'm gonna steal one from Polymars, which, to be honest, his makefile is just DevKit Pro's example makefile, so I could have just stolen that one instead. But it's like I always say, it's better to steal from the wealthy than to steal from the poor. After changing some things and typing the magic words, it was off to the races. There's no way it's just gonna compile first try. What? It was that easy? That's it? We could have been playing Slop on the Go this entire time? Whoa, let's not get ahead of ourselves. Sure, the runtime is compiling, but there's no input, no graphics, there's no way to load projects. Heck, it doesn't even launch yet because there's no DS-specific code running here. So let's change that. I first wanted a way to embed projects in the executable so I can easily test out the runtime and bypass the need of a menu, since like I said, at this point we have no graphics. The 3DS does this with the ROMFS, so you can put whatever assets you want in a folder, tell the compiler to use that folder for the ROMFS, and once compiled, all your assets will be nicely packed into a single executable that you can easily share around. DS Homebrew has something similar to this called the Nitro File System.
Nitro File System.
It's the same thing as the ROMFS. You put the thing in the folder, you tell it what to do in the code, and it works perfectly. Simple as that. Okay. Wait a minute, the projects are actually loading. Getting the controls to work was surprisingly easy too. Literally just copy and pasted the 3DS input code and removed all the buttons that weren't on the DS and it worked fine. At this point we were having fun seeing what projects would and wouldn't work because even without any actual graphics, it was still nice to put logging blocks inside of projects and see what printed out on the DS screen. Though it would be nice to actually see anything on the screen, so that's what I decided to do next. This is so fun and easy. Oh my god. You would not believe the mental turmoil I had to go through to get this stupid cat on the screen. You thought 3DS graphics were hard? SDL2? Those are cakewalks compared to the dark arts that is DS graphics programming. The DS has two different graphics modes, a 2D mode and a 3D mode. Now, you would think it's better to use the 2D engine. Scratch is 2D, but no. For this project, it's actually better to use the 3D mode and pretend it's 2D. The 2D engine is just super limited. For example, scaling and rotating sprites is not only harder, but it can only be done to a very small amount of sprites per frame. You also have to manage images not as a full image, but as 8x8 tiles. This is easy in normal games because you can pre-convert all your images in that tiled format to be easier to work with. But we literally can't do that here since Scratch lets you use any image file from anywhere. The 3D engine just lets us not have to worry about any of that, but it comes at a cost. You can only use 3D on one screen at a time, so I can use the top screen or the bottom screen, but not both at the same time, which for now I'm just gonna have to deal with, unfortunately. Okay, now I just gotta learn how to use the 3D engine. Okay, here we go. Just gotta do a bit of programming and... okay, nothing is showing up. Okay, let me just copy and paste this example and bang! We got a square, people. Okay, now that I know how to draw squares, I can use squares to represent sprites just as a test and bang! Like, dude, we're almost there. We just need to display the actual images. So, what do we need to do to get an image on the screen? Well, we need to take a normal image file, decode that into raw pixel data, then upload that data into the DS's video memory to get rendered onto the screen. Easy enough, right? I've actually done some of the decoding work already when doing the 3DS port, so we can just use that. But there's a big issue. Every decoded pixel is 32 bits in size, which isn't a lot on its own, but quickly becomes a problem with basically any image. The DS only has 656 kilobytes of video memory to store textures in, which is actually kind of a lie since the memory is split into like 6 different banks, and some of those banks need to be dedicated to different things like the screen, and it's kind of a weird system if I'm being honest. All this is to say that any normal Scratch project would instantly fill up the DS's VRAM, so we're gonna have to compress this data into something way smaller. Enter the PAL8 texture format. Instead of every pixel being defined by a color, you first create a color palette, then every pixel points to which color in that palette it wants to be drawn with. With this and the fact that each color is 16-bit instead of 32-bit, we end up saving over 4 times the amount of VRAM. Now we just have to put this all into practice and... no. Don't tell me. Don't tell me I have to. That is until I stumbled across a forum article about this same issue, and they had solved it by converting any normal image on your SD card into a Citra 2D image using some, and I quote, swizzle magic. So I did a bit of stealing and used that in my project. Yeah, I swizzle magicked everywhere. To get the background of the sprite transparent, it was really easy. I just had to tell the engine to make the first color in the palette be transparent, which means pixels can only ever be fully transparent or fully opaque. No in between. Better than nothing, I guess. We have sprites on the screen! We're basically done now. Oh. I guess I forgot to mention that a DS can only render an image with up to 256 colors. Anything more and we get whatever this is. Now, I could just say screw it and leave it like this since realistically, are you ever gonna use more than 256 colors in a DS game? But I knew I had to do something when even the logo looked like crap. In comes
color quantization.
Despite the name sounding like a programmer's worst nightmare, it's actually quite simple. If an image runs out of colors, any new color will just find an already existing one that's kind of similar. Easy. It's not the prettiest looking solution, but it's one that works. And again, you really shouldn't be using more than 256 colors for a DS game anyway. Now, we could call this port done, but I wanted to try and get audio working. But I am dumb and don't know the first thing about audio programming when it's something more low level than SDL. So I genuinely copy and pasted an example from MaxMod, which is a DS audio library that lets you stream WAV files. Surprisingly, after editing the example a bunch, it actually kind of worked. The problem was that it had a bunch of limitations and was just kind of breaking more and more over time, to the point where as of right now, audio is just disabled altogether due to how buggy it is. After that, and a few more things like being able to load projects straight from the SD card, the DS port is fully functional. So, how well does it run? That's what we're here to find out today. I got this random R4 card off of Amazon with this DS Lite, so we're gonna find out if Scratch Everywhere for the DS is any good. Check out this logo I made. Very epic, very cool. Check it out, guys. Scratch Everywhere. Only on one screen though, cause like I was talking about, 3D Engine can only be used on one screen. GG's. Whatever. What can you do about it? I have here Flappy Bird DS Edition that I made in like 10 minutes. Specifically for the DS. Oh, it's on the bottom screen. Look at how disgusting this bottom screen looks, bro. It's like a screen protector that I can't take off for some reason. Like, you can see the bottom screen in action. And like yeah, it's working at full frame rate, so that's good. But like, this is a really small project, so anything bigger, it might just run out of RAM, because the DS Lite, again, only has 4 megabytes of RAM. So you're gonna have to be, okay, I died. You're gonna have to be pretty selective with what games you try on this. Like, it's gotta be like really small if you're on a DS Lite. A DSi though has 4 times the amount of RAM, so you can obviously play much larger games with 4 times the amount of RAM. Here's it on the top screen. Again, it's working pretty good. Okay, let's try something a bit bigger, like this tile map project that I made. Oh, and we're out of RAM. Come on, Hopper Heroes has to work, right? Hopper Heroes? Come on. Oh! Oh! We got a logo! Okay, I don't think it's gonna work though. I think it's frozen. Yeah, oh! Not frozen! But definitely, definitely not. Not the fastest. So yeah, like I said, anything bigger than like the simplest projects ever are just gonna fold on the DS, bro. It's just gonna be a bad experience. But yeah, that's it. Another epic porting project done because I was bored. Hooray! I definitely missed a few details because this whole thing happened 6 months ago. Wow. Oops. But guys, it's the end of the video. Seasoned veterans will know what that means. Yup. Subscribe!